right, Truman. Ms. Ludo's virtual class, or just algebra. This is Unit B, and we will be going over linear functions and inequalities. Once again, I understand some of us are struggling with our Unit A results. If you would like to retake Unit A, you can take it immediately following the Unit B test, as I am going to be reteaching Unit A objectives in this one. The reason why I taught Unit A the way I taught it was because I wanted to see your way of thinking and to see how you solve problems. I was a little disheartened because few people attempted. The ones who did were outstanding. The few who were unsure still provided a way for me to know how to help. So please, do your work. Find a notebook and have your work continuously in one book. Write it so that you can look back and look at your previous work. What you don't want is a whole bunch of different pieces of paper in random corners of your room. You want to put them all in one folder, one notebook, so you can look at it. All right, me, I am a truly passionate and idealistic person. So I can feel strongly about something, even though that thing may not be true. The reason why I love math is it allows me to say, this is how I feel, what's really happening. So it's important for you to be able to solve problems. It's important for you to be able to take information, shore up what you know, and find what you don't know. So we're going to dive into word problems, because word problems to me make more sense. So what we're about to do is create tables from these word problems. We're going to look at domain and range in these word problems, and we are going to write linear equations and solve them in this lesson. All right, number one, overnight, after a heavy rain, the water level at a river is 34 feet. And the water is receding at a rate of 0.5 foot per day. Create a table reflecting the day and water level. So the day and the water level. So, so you have a river and this water is flowing through it. Right now, it's at 34 feet. And every day it goes down like a half a foot. So the first day after that heavy rain, that first day it rained is 34 feet. The next day is receding. Receding, you are taking away, you are subtracting. So 34, it's going to be 33 and a half. So every day, a half a foot, right? There we go. So 34, 33, 32, 31. This is going to be 30. Okay, there we go. 29 and a half. So this is 29, 28, 27, 26, 25. Okay, so 28 and a half, 27 and a half. Make sure my 7 looks like a 7. 20. Oh, these are the things we deal with. Cool. Oh, no wonder. Cool. 26 and a half. Oh, sorry about that. It's tricky. It's harder than it looks. 25 and a half. 24 and a half. So that's what it looks like. So with the rain, it got up to 34 feet. And after a day, it went down half a foot. After another day, it went down half a foot. All right. So next it asks, write an equation using L and D for how many days will the water level, and how many days will the water level be? And how many days will the water, okay. So first, an equation for this. So every day is going down, but it started at, right? Because anytime it says per or each, that's going to go with your variable. It's your job to figure out if that number is going up or down, because repeated addition or repeated subtraction is multiplication. So we're trying to find out how long it's going to take to get to 26 feet. Well, this says what? So on a table, you should be able to tell me what that number means. Well, if you look at that number, it happens to be in the day column. So this should be 16 days. That's what that is. But going back to Unit A, we can solve this. So this is going to be this equation equal to 26 feet. So if we know it goes down half a foot and it started at 34 feet, if we get rid of that 34, what is that? So Hmm. 30 minus 26, 2. I am messing up right now. So that, yep, that's 34. 26 minus 34. Ah, that was right. -8. Okay, that makes sense. Because if this goes down half a foot and we started at 34 feet, then I'm looking to see how long it takes to drop 8 feet. That makes sense. So if this goes down half a foot, I'm looking at how many halves are in 8. Because we're talking about things going down, we're talking about things going down. That makes sense. That this should be, what is that? Divided by, yeah. So that should be 16 days. That makes sense. Because there are, and this number should be positive because we're talking about days. Okay, that makes sense. All right, so going over here to my independent variables, the question becomes, which one's independent? First, let's start there. Your independent variable is your domain. Your domain is your x value or coordinate. We'll get into that. What controls the other thing? Well, my days tell me what the water level is. The water level doesn't tell me what the day is. So my x, my domain, are the days. And what days make sense? Well, all this happened because it rained really hard the night before. So going back in time doesn't make sense. So my days make sense. 0 to some larger number, but it's going to be a positive number. Because think about it, if this is going down half a foot every day, at some point I'm going to get to 0. that number of water level doesn't make sense that I would have a negative water level. We're not measuring droughts. Your range, so if your domain is X, your range is your Y. So if this is input, this is output. So if that's days, this is levels. And that level has to be positive. Like I said, I can't have negative numbers. So 0. No. Let me think about this. My Y can be equal to or less than 34, but it has to be larger than or equal to 0. So that's what domain and range does for us. So looking back at what we did, we talked about creating tables for linear functions, domain and range, write a linear equation and solve it in a problem. Talking about days and the water level, set up an equation, and actually we used the table to find out when it would be 26 feet. We talked about domain and range, and we stepped back to solve equations. Do your work on off weeks. This counts. Let's go, Trim.